Hi, everybody. I'm Paul Swangard, and welcome to Form Factor Mission Central, dedicated to exploring today's semiconductor world and its exciting trek into the future. Not since the rise of the World Wide Web has a technology captured the collective imagination the way artificial intelligence has. It promises to transform virtually every sector of the economy and our everyday experience as well. But without a parallel revolution in semiconductors, AI would still be a textbook exercise instead of a workable reality. Why? Because it places an enormous load on the processing hardware tasked with running it. Let's take a quick look under the hood to see why. The basic building block in most AI systems is the large language model, or LLM, which ingests huge amounts of data to gain an understanding of the real-world concepts and processes and to respond to them. Once trained, it can produce spectacular results, such as the human-like conversations we have with ChatGPT. But this training phase is no small feat. It involves the manipulation of an abstract architecture called a neural network through some highly sophisticated mathematics, such as tensor calculus. Ultimately, all this higher math breaks down into a massive set of primitive microcomputations. To train a GPT-3 LLM with 175 billion parameters, it might take weeks and use thousands of processing units, to say nothing of the cost and power consumption involved. Fortunately for AI, semiconductor technology has now entered the era of advanced packaging, which offers substantial performance gains along with reduced power consumption. It works by taking a chip's functional units, which were previously spread out across single layer, and restacking them vertically, all of which translates to less space, lower power, and higher speeds.
We're really taking these high bandwidth memory stacks and putting them on top of a GPU or CPU, which allows very high speed and very power efficient connections between the processing unit, the CPU or GPU, and the memory itself.
To be a workable solution, advanced packaging demands advanced testing technology, and FormFactor has more than stepped up to the challenge.
We're now building probe cards that test the entire wafer at once, over 100,000 individual probes, each about the size of a human hair, that carry an amp of current at tens, sometimes even hundreds of gigahertz signals in and out of the chip.
These large AI dies also require a lot of power to operate, so we provide MEMS-based pins with high current carrying capacity, exceeding a couple of amps per pin at times. And a less obvious challenge here is that pins designed to carry high currents aren't optimized for high-speed digital signals, and vice versa. So FormFactor has developed a unique capability called hybrid MEMS, whereby we can provide high-power probes and high-speed probes together on the same probe card. Also, when testing very large, high-powered processing units directly on a 300mm wafer, heat becomes a critical issue. FormFactor solves it by placing the wafer on a liquid-cooled mounting surface with multiple zones for heat control where it's needed. Artificial intelligence, advanced packaging, partners in a better future, all with FormFactor playing a vital role. I'm Paul Swangard. See you next time on Mission Central.